Let's start with the first case study implementation. We have done a separate lecture as well that how to use Google Colab for these case studies. So in fact, I'm not going to run these case studies right now. I'll be just explaining their code snippets and you people can have run with your on Google Colab. So in this first code snippet, what we are doing is that we are just mounting our drive. Whenever you mount this drive, Google is going to give you a link that you will click and you will get a key and you will enter that key over here. This way your Google Drive will be mounted with your Google Colab. The second step, we are actually importing the tar file, which is actually the data set that we have, and we extract it. Next, we have the natural language toolkit library imported. We have the string and email library imported as well. And then we download the punctuation, the latest punctuation for the English language, the stopping words for the English language using this NLTK library. In the next, you can see over here that we have a function which will be called in the main function flatten to string. So it is actually converting different parts of the email messages to a set of strings, and it is returning those strings. Then this is actually the another supporting functions for the main function that is coming down. So we actually call the flatten to string function here in the extract email text as well. And then we have the load function, which is actually calling this extract email text function. And actually what it is doing is that it is actually removing the punctuations and also the stemming words from the given email message. Now, this is the main function of this case study. So it is actually taking the data set, which we have just unzipped, and then we have the into data, and then we have the labels file into the directory index. And what we do is that we split the data set into training and testing data set. So we have xtrain and xtest. Actually, what we do is that we load the file that we have already used the function, and then we see that if stemming is not already done, we continue, and if label is equal to 1, this means that this is a normal file, and we update all the stemming words in the ham words. And if the label is 0, this means this is a spam file, and we update the words of all stems that we get from the load function into spam words. And the blacklist set of words are those which are in the spam minus the ham words. Now, this is the last function that we use to test actually how exactly this approach is working. So we are again calling the load function, and if the stemming is not applied, we just continue. And if the stemming is applied, so we have stem set not empty, and we also have the set of blacklist words. Now we check again if the label is 1, that is the file is a ham file or clear file, but the blacklist and the stem set appears for this file. This means we hit a false positive. So the decision was wrong, else the decision will be true positive. It will be incremented. Similarly, if the label is 1, right, but the true negative is actually and if the stem set and the blacklist is not true and still the label is 1, this means we hit a true negative. The system is saying that the file is ham, whereas it is spam. And else, if this condition is not true, we have a false negative counter incremented at 1. We print actually the confusion matrix with true negative and true positive and false negative. We get their approximation as well in the percentage, like 32%, 3.6%, and 27.7% and 36.1%. And the overall classification accuracy is actually true positive plus true negative divided by the whole count that we have encountered here. So this is 68.7%. This is the whole case study that we have implemented over here. Thank you.